Welcome to This Explainer. Right off the bat, we're going to completely shatter that neat, linear ape-to-man illustration you probably saw in grade school. You know the exact one I'm talking about, right? It shows a chimp-like creature slowly standing up, getting a bit taller, losing its body hair, and then confidently holding a spear at the end. It's a beautifully simple story. But, as we're about to see through some absolutely incredible recent discoveries, it's also completely wrong.
Okay, let's dive right in. New archaeological and genetic discoveries are proving that our history actually isn't some straight, single-file line of progress. Instead, it's this incredibly chaotic, intertwined web of multiple human species sharing the planet, sharing technology, and, as we'll see in a bit, sharing a whole lot of DNA. So we aren't the pinnacle of a lonely evolutionary ladder, we're actually just the last surviving members of a seriously messy family tree.
So, over the next few minutes, we're going to systematically dismantle those old assumptions to reveal a much richer and honestly, vastly more complex reality. We're going to look at the hard evidence that practically forces us to rethink what it means to be human. And we'll kick things off with a fundamental milestone in our evolution, the very first inventors of technology.
Section 1. The first toolmakers. Now, for decades, the prevailing thought was that our direct genus, Homo, invented tools around 2.6 million years ago in places like Gona, Ethiopia. The legendary Lomquis family heavily entrenched this idea back in the 1960s, basically insisting that toolmaking was an exclusive hallmark of our direct lineage. But when you start tracing the timeline further back, wow, the Earth gives up some entirely different secrets. Researchers stumbled upon the Lomquis site down in Kenya and uncovered jaw-dropping 3.3 million-year-old stone tools. I mean, that completely predates the existence of the Homo genus. These weren't made by humans as we define them. They were crafted by older, much smaller-brained hominins.
So, having a chimp-sized brain didn't stop these early hominins from being brilliant innovators. As anthropologist Tom Plummer pointed out, the fact that we found what's probably the earliest Oldowan site and that the hominin found there is Paranthropus really makes us reconsider whether the traditional assumption of Homo as the first toolmaker should even be made anymore.
Let's look at exactly what Plummer's team found at Nyanga. They didn't find Homo habilis. Instead, they found the massive teeth of Paranthropus, often called Nutcracker Man because of its huge jaws, lying directly alongside stone tools that were actually used to butcher hippos. It is absolutely astounding. And we also now know from studying hand and wrist anatomy that these earlier species, including Australopithecines, possess the crucial precision grip necessary to strike rocks together. It proves, definitively, that our direct ancestors absolutely did not hold an exclusive patent on technology.
Moving right along to Section 2, discovering the Denisovans.
For a really long time, the Denisovans were practically ghosts. Incredibly, they were first identified back in 2010, not by some beautifully complete skeleton, but from ancient DNA extracted from a tiny, juvenile pinky bone found in Siberia's Denisova cave. Literally, just a single pinky bone. But recently, through some pretty amazing advances in proteomics and genetics, they've been linked to a species known as Homo longi. These extinct archaic humans from Asia roamed around from roughly 200,000 to 32,000 years ago, and they are completely rewriting our understanding of archaic humans.
And what's truly staggering here is the sheer scale of their territory. They weren't just huddling in a single Siberian cave. We have fossil evidence of them surviving everywhere from the freezing, low-oxygen extremes of the Baishia Karst cave up on the Tibetan plateau, all the way down to the humid tropical forests of Laos and even oceanic channels near Taiwan. They were incredibly adaptable, conquering environments that we previously thought only modern Homo sapiens could possibly master.
Thanks to the breathtaking Harbin cranium, famously known as Dragon Man, we finally know what they looked like. And they were impressive. They had massive brains, around 1,420 cubic centimeters, rivaling and sometimes even exceeding our own. They had the longest archaic human skulls ever found, adapted large, flat faces with wide noses specifically for breathing cold air, and possessed massive molars like much older ancestors. Plus, they completely lacked a chin. They were just these physically imposing, highly intelligent survivors.
Which brings us to Section 3, a tangled genetic web. So when we break down a Denisovan genome from Siberia, we find this explosive genetic mosaic. Yes, 79% of it is what we classify as Denisovan ancestry. But check this out. An astonishing 17% comes directly from local Neanderthals, and a fascinating 4% traces back to a totally unknown million-year-old super-archaic human species, meaning they were out there mixing with hominins we haven't even discovered the fossils for yet. It's wild.
And all this builds to what might just be one of the most astonishing discoveries in the entire history of archaeology. Deep in that Siberian cave, scientists literally found the bone of Denny. Denny was a first-generation teenage girl, not someone with, distant mixed ancestry. She literally had a Neanderthal mother and a Denisovan father. Finding a first-generation hybrid like this strongly suggests that when these different ancient human groups met, interbreeding wasn't just some rare anomaly, it was likely a super common occurrence.
And that leads us perfectly into Section 4, our shared human legacy.
Because this tangled web of ancient romance didn't just stop with Neanderthals and Denisovans hanging out in caves. It directly shaped us. Roughly 5% of the DNA in modern Melanesians, Aboriginal Australians, and Filipino Negritos, specifically the Aita-Magbukan people who have the highest known proportion in the world, comes directly from Denisovans. When our modern human ancestors migrated out of Africa and across Asia, they met Denisovans, they mated with them, and they carried that exact genetic legacy forward.
And this isn't just some fun quirk of ancient history either. It's active, functioning biology. Denisovans spent thousands of years adapting to harsh, high-altitude climates like Tibet. When migrating modern humans arrived and interbred with them, they inherited those hard-won genetic adaptations. Fast forward to today, and modern Tibetans literally possess the EPA-S1 gene, a direct inheritance from Denisovans, which actually allows them to thrive at extreme low-oxygen altitudes. So Denisovan DNA is actively helping humans survive today.
So, as we wrap up this explainer, we really have to face a beautiful, humbling truth. We aren't the sole inventors of technology, and we certainly aren't a pure, isolated species sitting pretty at the top of a linear ladder. Our deep past is this diverse, shared legacy of brilliant hybrids and early, small-brained, tool-making cousins. It leaves us with a pretty provocative question to ponder. If our tool-making, our adaptability, and even our very DNA are deeply shared with vanished cousins, what truly makes us unique? Thanks for hanging out with me on this journey, and keep questioning the story of us.